was a better model, we'll have to shoot for 3.27% per year. And remember the historic figure on the preceding slide, 6% per year. If that could continue for one lifetime, Boulder would be larger than Los Angeles. Now, this isn't Boulder plus Broomfield, Louisville, Lafayette, the other towns in the county. This is just Boulder. Well, it's obvious you couldn't put Los Angeles in the Boulder Valley. Therefore, it's obvious Boulder's population growth is going to stop. Now, the only question is, will we be able to stop it while there's still some open space, or will we wait until it's wall-to-wall people and we're all choking to death? Now, it's interesting to read what the boosters say. Some years ago, we read that doubling its population in 10 years, Boulder is indeed a stable community. What in the world are they talking about? You're going 100 miles an hour, 7% growth per year, doubling in less than 10 years, and someone makes the idiotic statement that we're stable. We're standing still. We're not moving. They don't even understand the meaning of the words that they put down on paper. Well, every once in a while somebody says, but you know, a bigger city might be a better city. And I have to say, wait a minute. We've already done that experiment. We don't need to wonder what will be the effect of growth on Boulder, because Boulder tomorrow can be seen in Los Angeles today. And for the price of an airplane ticket, we can step 70 years into the future and see exactly what it's like. And what is it like? Well, here's an interesting headline from Los Angeles. That headline probably has something to do with this headline. So, well, how are we doing in Colorado? The Denver Post tells us that we're the growth capital of the USA and proud of it. The Rocky Mountain News tells us to expect another 1 million people in the Front Range in the next 20 years. But in the Post there was an interesting story. Someone was quoted as saying Colorado has a 3% growth rate. That's like a third world country with no birth control. We send foreign aid, family planning assistance to countries that have smaller population growth rates than Colorado has. Well, as you can imagine, growth control is very controversial, and I treasure the letter from which these quotations are taken. Now, this letter was written to me by a leading citizen of this community. He's a leading proponent of controlled growth. Now, controlled growth just means growth. This man writes, I take no exception to your arguments regarding exponential growth. I don't believe the exponential argument is valid at the local level. So you see, arithmetic doesn't hold in Boulder. Now I have to admit, that man has a degree from the University of Colorado. It's not a degree in mathematics, in science, or in engineering. Let's look now at what happens when we have this kind of steady growth in a finite environment. Bacteria grow by doubling, and one bacterium divides to become 2, the 2 divide to become 4, the 4 become 8, 16, and so on. Suppose we had bacteria that doubled in number this way every minute. Suppose we put one of these bacteria in an empty bottle at 11 in the morning and then observe that the bottle's full at 12 noon. Now there's our case of just ordinary, steady growth. It has a doubling time of 1 minute. It's in the finite environment of one bottle. I want to ask you 3 questions. Number 1, at what time was the bottle half full? Well, would you believe 11:59, 1 minute before 12, because they double in number every minute. And the second question, if you were an average bacterium in that bottle, at what time would you first realize that you were running out of space? Now think about this. This kind of steady growth is the centerpiece of the national economy and of the entire global economy. Think about it. Well, let's just look at the last minutes in the bottle. At 12 noon, it's full. 1 minute before, it's half full. 2 minutes before, it's a quarter full, then an eighth and a 16th. Let me ask you, at 5 minutes before 12, when the bottle's only 3% full and is 97% open space just yearning for development, how many of you would realize there was a problem? Now, in the ongoing controversy over growth in Boulder, someone wrote to the newspaper some years ago and said, look, there isn't any problem with population growth in Boulder because, the writer said, we have 15 times as much open space as we've already used. So let me ask you, what time was it in Boulder when the open space was 15 times the amount of space we'd already used? And the answer is it was 4 minutes before 12 in Boulder Valley. Well, suppose that at 2 minutes before 12, some of the bacteria realize that they're running out of space, so they launch a great search for new bottles. And they search offshore, on the outer continental shelf, in the overthrust belt, and in the Arctic, and they find 3 new bottles. Now, that is a colossal discovery. That discovery is 3 times the amount of resource they ever knew about before. They now have 4 bottles. Before the discovery, there was only 1. Now, surely, this will give them a sustainable society, won't it? Well, you know what the third question is. How long can the growth continue as a result of this magnificent discovery? Well, let's look at the score. At 12 noon, 1 bottle's filled. There are 3 to go. 12:01, 2 bottles are filled. There are 2 to go. And at 12:02, all 4 are filled, and that's the end of the line. Now, you don't need any more arithmetic than this to evaluate the absolutely contradictory statements we've all heard and read from experts who tell us in one breath we can go on increasing our rates of consumption of fossil fuels. In the next breath they say, but don't worry, we'll always be able to make the discoveries of new resources that we need to meet the requirements of that growth. Well, some years ago in Washington, our Energy Secretary observed that in the energy crisis, we have a classic case of exponential growth against a finite source. So let's look at some of these finite sources. From the work of the late Dr. M. King Hubbard, we have here his semi-logarithmic plot of world oil production. The line's been approximately straight for over 100 years, clear up here to the year 1970. Average growth rate, very close to 7% per year. So it's logical to ask, well, how much longer could that 7% continue? Well, that's answered by the numbers in this table. In the top line, the numbers tell us that in the year 1973, world oil production was 20 billion barrels. The total production in all of history, including that 20, was 300 billion. The remaining reserves, 1,700 billion. Now, those are data. The rest of this table is just calculated out. Assume that the historic 7% growth continued steadily each year following 1973, exactly as it had been for the preceding 100 years. Now, in fact, the growth stopped. Not because of the arithmetic, it stopped because OPEC raised their oil prices. So we're asking, what if? Suppose the growth had continued. Let's go back to the year 1981. By 1981, on the 7% curve, the total usage in all of history would add up to 500 billion barrels, the remaining reserves 1,500 billion. The reserves at that point are 3 times the total of all that have been used in all of history. That's an enormous reserve. But what time is it when the remaining reserve is 3 times the total of all you've used in all of history? And the answer is 2 minutes before 12. Well, we know for 7% growth, the doubling time is 10 years. We go from 1981 to 1991. By 1991, on the 7% curve, the total usage in all of history would add up to 1,000 billion barrels. There'd be 1,000 billion left. At that point, the remaining oil would be equal in quantity to the total of all that we had used in something like 130 years of the oil industry on this earth. By most measures, you'd say that is an enormous remaining reserve. But what time is it when the remaining reserve is equal to all that you've used in all of history?